We know that acids and bases can be dangerous. We know that sometimes acids can burn your skin. We know that bases can be very, very corrosive, and they can damage your skin as well. And the video that you saw, the acids can actually eat apart the metal. And that's pretty strong. That can be pretty dangerous. The question that we want to answer today, though, is what affects how dangerous an acid or a base actually is. And there are actually two factors that are going to affect how dangerous that acid or base is. The first one is a concept that we actually talked about in the last chapter, and it is the concept of concentration. I believe hopefully you'll remember the example I gave you then where I talked about chlorine. And I said if you have chlorine in your drinking water, it's not very concentrated. It's very, very dilute, and it's just there to kill some bacteria so that you don't end up getting sick. But the chlorine in a swimming pool is much more concentrated. You go into a swimming pool, you can often smell the chlorine. And for some people, it actually irritates their skin to be in chlorinated water for too long. They have to make sure they shower when they get done being in a swimming pool. But if you use muriatic acid, which is often used for cleaning, that is really, really, really strong, and you've got to be really careful with that stuff. It's all chlorine, but the concentration of it, how much of it you're putting in a solution of water, is going to determine, how much of that acid is there, how much of the base is there. In the case we were talking about, how much chlorine is there. And so how dangerous is it depends on how much you've put in with the amount of water that you have there. So concentration affects the strengths of acids and bases, just like we talked about before. But there's another characteristic of acids and bases that also is going to affect how dangerous or how powerful they are, and that is called the strength of them. Now, what exactly do I mean by the strength of an acid or a base? We have talked about the fact that when you put an acid or a base into water, it breaks apart into ions. So if I have hydrochloric acid or HCl and I put it into water, it will break apart into hydrogen ions and chloride ions. And when I do that, this is if it is in water, and I always have to specify that I'm talking about if I put these acids or bases in water. So if I put them in water and they break apart, this breaks apart all the way. Every single molecule of hydrogen chloride is going to break apart into hydrogen ions and chloride ions. Every single one in there is going to do that. So if all of it ionizes, it is called a strong acid. Okay? You can also have a strong base. And so if I have NaOH, which we also talked about, NaOH is a strong base. And so if I put NaOH into water, it will break apart so that I have sodium ions and hydroxide ions, and I won't have any left that looks like this. All of it will break apart into ions. So all of it will ionize. So again, all of it ionizes, and so therefore it is called a strong base. Now, not all acids and bases are that way. I have some acids and bases where only a part of it will ionize. And so if I give you an example of that, we talked about acetic acid, which is in vinegar. Okay, so I'm just going to write vinegar up here to help you remember that. Vinegar is a solution of acetic acid in water. So again, this is in water also. Anytime we're talking about this, it has to take place in water. And so I talked about how it would break apart into hydrogen ions and then what are called acetate ions. And I don't expect you to recall the name of that or how to break it apart. Just know that this front hydrogen ion breaks off. But over here, every single one of these breaks apart into ions. But over here, that is not the case. And so in place of just putting one arrow going this way, I'm actually going to put a double-headed arrow to show that not all of it breaks apart. So here, only part of it ionizes. And if only part of it ionizes, then it's called a weak acid. And the more ions that you have in solution, the stronger that acid is. So you're going to have some acids that break apart just a teeny little bit. Some of them, maybe half of it will break apart. Some of it, almost all of it breaks apart, but not quite all of it. And so there's a range, there's a continuum of how strong your acids are, and it all depends on how much of it ionizes in solution. You can have a weak base as well if you're familiar with ammonia. A lot of times ammonia is used in cleaning. If you have window cleaner, a lot of times you're going to have ammonia in that window cleaner. And so ammonia actually looks like this, NH3. It's a gas, and then you actually take that and you do dissolve it in water. And so if I add water to this, what happens is that one of the hydrogen ions from the water actually gets pulled over here. And so I end up with NH4 plus and OH minus. Oh, look, there's that OH minus. There's that symbol of a base that I see because this is actually a gas. Okay? And again, you'll see that I got this double-headed arrow in here, which means it doesn't all go this way. Only part of it does. Only part of it ionizes. And so again, if only part of it ionizes, you have a weak base. Now, I don't want you to get scared here. I do not expect you to write these kinds of equations. Here's what I expect you to know. A strong acid or a strong base means that all of it ionizes. So there's nothing left but ions. And so with all those ions, that makes it strong, okay? Similarly, if only part of it ionizes, breaks apart into ions, then you're going to have a weak acid or a weak base. I kind of think of it this way. I have a couple of sons who really enjoy weightlifting. And so if I think about this, this big barbell with all these weights on it, and they'd be really good at picking that thing up. And so if my sons would pick that up, they're going to look like this. So they're going to, well, they wouldn't hold on to it there. They'd hold on to the barbell part. And so they've got these really big muscles, and they're really strong. And so they got all these big muscles in their chest, and then their legs are muscular. And so they're going to look like this when they pick up this barbell, okay? I never claimed to be an artist, okay? But anyway, this is supposed to represent this great, big, huge, strong guy lifting this big barbell with all these weights on it. He is strong. He lifts up all of it, okay? Now, when I go downstairs, if I'm going to, because we have this like sort of almost like a weight room set up on our basement, and so if I go down there and I'm going to clean stuff up, and if they happen to leave this big barbell sitting on the floor, which they normally don't, they're really good at cleaning up after themselves, but if they did, if they left this big barbell sitting on the floor and I'm going to try to move that, what's going to happen? Well, I'm going to go over here, and this is going to be me. I'm going to have this here like this, and I'm just going to barely be able to lift this thing up off the floor. I might lift up maybe one end, but not the other end, because they are strong and I am weak, and they're going to lift up all of it. I'm weak. I'm going to lift up just part of it. I won't even be able to get the thing off the floor. Okay? So they lift it all. I'm weak. I lift part of it. Similarly, a strong acid has all of it ionized. A weak acid has only part of it ionizing. Okay? So that's the big idea that you need to remember for today. So two things that are going to affect how powerful or how dangerous, not just how dangerous, but also how powerful, because sometimes you want these acids and bases to do work for you. And so how powerful or how dangerous they're going to be. One of it has to do with how concentrated it is, and the other factor has to do with the strength of that acid or base and how much it ionizes in solution.